Today we're going to be talking about the Pythagorean Theorem for right triangles. Here's a diagram of a right triangle. The longest side is the hypotenuse and the other two sides are called legs. And in a right triangle, if you take the length of the legs squared plus the length of the other leg squared, it will be equal to the length of the hypotenuse squared. Or in other words, you probably know this as a squared plus b squared equals c squared. A and B stand for the two legs, and C is the hypotenuse. So let's try this. Here you're given a right triangle, and we know the lengths of the two legs, but we'd like to find the hypotenuse. So let's use A squared plus B squared equals C squared. So in this case, A is 12, B is 16, and C is your x. So we have 12 squared plus 16 squared equals x squared. So I have 144 plus 256 equals x squared. So we have 400 equals x squared. Simplifying that, we're going to have to take the square root of 400 to get our x value. So square root of 400 gives us a value of 20 for x. Let's move on. Here we're given another right triangle. We have our Pythagorean theorem that we're going to be using to find our third side. In this case, we know that one of the legs is 8. We don't know the other leg, so we'll just call it x for b. And the hypotenuse, the longest side, is 12. The hypotenuse is always directly opposite the side opposite the right angle. So let's plug our numbers in. We have 8 squared plus x squared equals 12 squared. So we have 64 plus x squared equals 144. Subtract 64 from each side to find x. So we get x squared equals 80. But now, to actually find x, we take the square root of 80. And we do want to round that. Let's round it to the nearest hundred. So we get x is approximately 8.94. Let's try this next one. Find the length of an altitude of an isosceles triangle with sides of 6, 6, and 10. I'm going to draw, or at least attempt to draw, a diagram to represent this. So here's our diagram. And I do want to draw in my altitude. This is an isosceles triangle with sides 6, 6, and 10. And my altitude, remember, forms a right angle with the opposite side. So now what this gives me, since I'd like to find the length of my altitude, that would be x right here. Now, what I'd like to do is just sketch one of these little triangles. And again, this is not going to be to scale, but it will at least give us something to look at here. So here's one of the triangles. The hypotenuse is 6. Now, remember, if this side is 10 and the altitude, this is an isosceles triangle, so this altitude is going to bisect this side of 10. So what we're going to end up with is 5 and 5 here for each length. So I'm going to have a hypotenuse of 6 and a leg of 5, and I'm going to want to find the other leg, which will be my altitude. So we'll use the Pythagorean theorem, a squared plus b squared equals c squared. And let's say that a is your x, b is 5, and c is 6. We'll plug our numbers in, so we have a squared plus 5 squared equals 6 squared. So I have a squared plus 25 equals 36. Subtract the 25 from each side. And I end up with a squared is equal to 11. So now to find a, I take the square root of 11. And when I do that, rounding your answer to the nearest hundredth, we get a is approximately 3.32. So that is the length of the altitude. Moving on to the next page, Chance tried to get the attention of his friend by throwing rocks at her window, but she didn't hear him. He got a ladder from the garage and placed it 6 feet from the base of the house. If his friend's window is 19 feet from the ground, how long does the ladder have to be? This is so he can get his friend's attention. All right, so let's see if we can draw a picture of this. We've got this house, and here is your window. Here's the side of the house up to the window. Now, the ladder is being placed 6 feet away from the house, and of course this isn't drawn to scale. And what we would like to know is how long does this ladder have to be? Now, we do know that the window is 19 feet from the ground, and here is your ladder. So this is what we're trying to find. This is our x. So let's use our Pythagorean theorem. We have a squared plus b squared equals c squared. And in this case, we know a is 6 and b is 19. And let's plug our numbers in. We're trying to find c, which is our x, our longest side. Oh, and by the way, here's our right angle, of course. So we have 6 squared plus 19 squared equals x squared. So we have 36 plus 361 equals x squared, which gives us 397 equal to x squared. And then we have to take the square root of 397. And if we round that to the nearest hundredth, we have that x is equal to approximately 19.92 feet. So the ladder is going to have to be at least 19.92 feet long to reach the window. Let's move on. We're going to be talking about Pythagorean triples. Pythagorean triples are any 3 whole numbers which work in the Pythagorean theorem. So in other words, is it true in this case that a squared plus b squared equals c squared? So in other words, is it true that 3 squared plus 4 squared equals 5 squared in this case? And, well, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And sure enough, 9 plus 16 is 25. So 3, 4, and 5 is makes a Pythagorean triple. Let's try the next one. Does 5 squared plus 12 squared give you 13 squared? I'm kind of running into some of the other problems, but let's draw a line down through here. Okay, so we've got 25 plus 144. Does that give you 13 squared of 169? And it sure does. So yes, 5, 12, and 13 are Pythagorean triples. This next one, 12 squared plus 16 squared. Does that give you 20 squared? Let's see, 12 squared is 144, 16 squared is 256, and 20 squared is 400. And is it true that 144 plus 256 gives you 400? Absolutely. So 12, 16, and 20 are Pythagorean triples. Next we have, does 8 squared plus 15 squared give you 17 squared? Well, let's see. 8 squared is 64, sorry. 15 squared is 225. 17 squared is 289. Is 64 plus 225 289? It sure is. So 8, 15, and 17 are Pythagorean triples. So here you've been given examples of 4 Pythagorean triples. Now, if you want to know if this is a right triangle, see, do these 3 numbers make a Pythagorean triple? Take the 2 smaller ones, square them, and add them together, and see, does it equal the larger number squared? Well, 5 squared is 25, 10 squared is 100, and 14 squared is 196. So is 25 plus 100 equal to 196? Absolutely not. So no, these sides don't make a right triangle. Moving on to the next page. If c squared is less than a squared plus b squared, you have an acute triangle. We already know that if c squared equals a squared plus b squared, you have a right triangle. And the last thing I'm going to give you is if c squared is greater than a squared plus b squared, you have an obtuse triangle. So we want to know what type of triangle is each one. So take your largest number and square it, and then square the other two and add them, and see what kind of a symbol you need to put in between them. Greater than, less than, or equal to. So we have 49 plus 9, which gives you 58. And then on the left side, 9 squared is 81. Is 81 less than, greater than, or equal to 58? It's greater than. So if we use a greater than symbol up here, this is obtuse. Let's do the next one. Take the largest number, square it. Take the other two, square it, and add them together. We have 49, 36 plus 25. So we get 36 plus 25 is 61. So is 49 less than, greater than, or equal to 61? It's less than. Well, the less than symbol goes with the acute triangle. So this one's acute. Let's look at the next one. Square root of 14, 5 and 8. Well, 8's actually the bigger number, so we're going to have 8 squared. Square root of 14 squared, and plus 5 squared. So we want to know. 8 squared is 64. Square root, if you square the square root of 14, you just get 14 back. And 5 squared is 25. Well, 14 plus 25 gives you 39. And 64 is greater than 39. And going back up to the top, if you use a greater than symbol, it is obtuse. Try the last one on your own, and we will go over that in class. Thank you for joining me.